Now see the sixth property here. So sixth property is about error function of x is equal to the 2 upon root pi. You can observe this is in terms of x. So we call it a series of ascending powers of x. This sixth properties tell us that the error function can be expressed as a series form also. How it is? For that, see the proof here. Again, definition of error function is 2 upon root pi integral 0 to the x e raised to the minus u square du. Now here it is contained e raised to function. So everyone know that the expansion of e raised to x is 1 plus x square upon 2 factorial plus x cube upon 3 factorial and so on. Similarly, we can write for e raised to minus u square. So we just replace x by minus u. So we obtain it as 1 minus u square plus it is x square, that means u raised to it is 4 plus u raised to 4 upon 2 factorial is 2 plus it is minus, if x is replaced by minus u square, we will obtain it is plus u raised to it is 6 upon here 3 factorial is 6 and here is it is negative minus and so on. So put this value of e raised to minus u square in this integral. So we obtain error function of x is 2 upon root pi integral 0 to the x and value of e raised to minus u square is 1 minus u square plus u raised to 4 upon 2, it is minus u raised to 6 upon 6 and so on and du. Now integrate term by term with respect to the u. So we obtain here 2 upon root pi integration value of 1, it is u minus u cube upon 3 plus u raised to 5 upon 5 into 2 minus u raised to 7 upon 7 into 6 and onwards. And now put the limits. So if we put into whole term is upper limit, that is u is x, then we obtain x minus x cube upon 3 plus x raised to the 5 upon 5 into 2 is 10 minus x raised to the 7 upon 7 into 6 is 42 and onwards. If we put it is lower limit, so whole term is contain u. So u if it is 0, then whole term answer is 0. So we obtain here error function of x is in terms of x. Now see the seventh property here. Seventh property is differentiation of error function. The differentiate error function and answer will be 2 upon root pi e raised to the minus x square. So see here how to differentiate error function. Again here by definition we can write error function of x is 2 upon root pi integral 0 to the x e raised to minus u square du. This is our definition of error function. Now we need to differentiate. So differentiate with respect to the x. So it is d by dx. Error function of x is equal to the 2 upon root pi and differentiate this integral with respect to the x. Now here is we use a one concept of DUI's rule. So what is that rule? So here is apply a DUI's rule, that is differentiation under integral sign. So according to this DUI's rule we can write 2 upon root pi integral 0 to the x and this derivative we take inside the integral, so it become a partial derivative and function is e raised to minus u square du plus here is a function is replaced by upper limit. So here is function is e raised to minus u square, and differentiate upper limit with respect to the x. So it is x here, minus function is replaced by lower limit, that is e raised to minus u square is replaced by u, and differentiate a lower limit with respect to the x. So it is 2 upon root pi as it is. Here is differentiate partially with respect to the x, but here it is a function in terms of u which is to be treated as constant. So answer of this derivative is 0. Plus here is u is replaced by x, so answer will be e raised to minus x square, and derivative of x with respect to the x, that is 1, and minus here is lower limit is 0, so the answer is 0 here. Now left terms are 2 upon root pi, and it is e raised to minus a square. So this is the value of derivative of error function of x. So here it is, answer is in terms of x. Thank you students.